All right, welcome back. So this is the practice problems portion of solving systems of linear equations by the elimination method. So what we're going to do here is just walk through the process that you're going to apply so you can get some extra practice solving these kinds of problems. So remember what we are looking for. What we want when it comes to a solution for a system of linear equations, and let's just get this set up, is I want some number for x and some number for y. And it's going to be the same x and the same y that fulfills both equations. Right? So the process that we have to look at is ultimately we want to be able to just add these two equations together. So if I add these two equations together right now, are there terms that are just going to cancel each other out? If I add 4x and 3x, is that going to zero anything out? If I add 3y and 5, sorry, a negative 3y and 5y together, is something there going to cancel itself out? No, no. So if something would naturally cancel out, then I would just be able to go ahead and do that. But nothing's going to cancel out here. So I have to do something. Now, I have to multiply one or both of these equations by some number. Now, to determine whether it's one or both, let's say, for example, if this bottom equation was just y, then it would be 3x plus y equals negative 7. Well, if that were the case, I could take this bottom equation, let me change colors back to black, and if I just multiplied this whole thing by a positive 3, okay, and I'd have to do that to both sides, multiplied by positive 3. 3 times 3x would give me a 9x. 3 times y would just give me a positive 3y. Negative 7 times 3 would give me a negative 21. Okay, so now, between these pairs, this negative 3y and this positive 3y would naturally cancel. So that would be an example of an equation where I would really only have to multiply one equation by something. However, here that's not the case. So I'm going to have to multiply both equations by something. And that something is just going to be a number, and it's a different number for this equation versus this equation. The goal is I want to make some pair of numbers, and one of these pairs of variable terms, into additive inverses of each other. Meaning it's the same number, but one's positive, one's negative. All right, so I'm going to multiply the top equation by something, and then the bottom equation by something else, so that when I add these equations together, something will cancel. Okay, so it is a little bit of a decision-making process to which one you're going to do, but I'm looking here, this negative 3y and this positive 5y, well, they're already opposites as far as their signs go. So if I just multiply this top equation by something to make this 15y, I can multiply this by something to make it 15y. And really, we're just multiplying by the other coefficient. But so let's do that. Let me make this thing a little bit finer here. Okay, so I'm going to rewrite my original equation here. Okay, so 4x minus 3y equals 10. So I'm going to multiply this side and this side by 5, positive 5, right? Because I want to keep this as a negative. So 5 times 4 is 20, so that's 20x. And let me just do a little bit of erasing here to make sure I've got some room. 5 times negative 3y, because remember, this is just applying the distributive property. So minus 15y equals 10 times 5, because if we do something to one side of an equation, we got to do the same thing to both. 50. Okay. Now let's do the same process here with the bottom equation, with equation number 2. 3x plus 5y equals negative 7. Multiply this side by something that's going to make that a positive 15. Well, it's 3. Notice how these numbers kind of cross over. And then I'm going to multiply this side, of course, by 3. So 3x times 3x is 9x. 3 times 5y is a positive 15y. And negative 7 times 3 is negative 21. Okay, great. Now we have two equations where when we add these together, this pair of terms is going to cancel each other out. A negative 15y plus 15y is just 0, so they cancel each other out. All right, so 20x plus 9x, well, that's a 29x, equals, well, 50 minus 21. Well, lo and behold, 50 minus 21 is 29. We divide both sides by 29, and we get x equals 1. Great. Well, now we have x equals 1. We have half of our answer, right? Because we found the x, now we just need to find the y. So we take that value for 1 and we stick it back into either of our original equations, doesn't matter which, and we just solve that for y, and then we have the other half of our solution. So let's do equation 1 for no other, well, we'll do equation 2. Why not? All right, so 3 times x, but it's not x anymore. We know x is 1. So that's just a 1. 3 times 1. Plus 5y equals negative 7. So now we have the tools already in our little mathematical toolkit here, so we can solve for that. We simplify this. 3 times 1 is just 3, plus 5y equals negative 7. Now we're just to a two-step equation. We subtract 3 from both sides. Those cancel out to 0. So I have 5y equals negative 7 minus 3, negative 10. Down to a one-step equation. Divide both sides by 5, and I get y equals negative 10 divided by 5. Our signs are opposite, so the result will be negative. 10 divided by 5 is 2. Negative 2. Great. Now, some systems of equations, like I said, if this original equation, this original coefficient over here was already negative 5y, well, then we could just add those together. Those will cancel out. If this was no coefficient here and it was just negative y, then we only have to multiply this top equation by 5. And we could do this for any of the variables that are in there. It doesn't have to be y. This example, though, we had to multiply both equations by something so that one of those variable terms is going to cancel out. Okay? Now, this looks like a lot of writing, and sometimes it can be, but as long as you're organized and don't try to take up the entire page, this is something that we can do as long as we follow this same process. Okay, so good luck with these. If you still need some help, just ask, let me know, and then we can walk through some of the other examples together. Okay, good luck.